In this video, we are going to do these 4 questions from the chapter limits, and these questions are based on the standard limits, that is tan x over x equals 1, limit x tends to 0, and sin x over x is equal to 1. At the same time, we'll also be applying some trigonometric identity. Let's begin with the first one. In the question, we have to evaluate this, right? 1 minus cos 4x over x, and the limit here is limit x tends to 0. Now, the first thing that we will do here is to convert 1 minus cos 4x as applying this identity, right, in terms of sign. So this is limit x tending to 0. So 1 minus cos 4x would become what? 2 sine square. 4x would become 2x, right? As 2 theta becomes theta. So that is half angle property. So this is 2x, and that divided by x. Now from here you can figure out that in order to apply this identity, we need to make it at the denominator we need 2x whole square, right? So for that, first I'll do what? I'll multiply over by x and divide by x. Further, I can see that we need 4. So I'll multiply by 4 and divide it by 4. Now let's figure out that what numbers 4 and 2 can be placed outside the limit. So we'll have 2 into 2 into 4, that is 8. And this is what? Limit x tends to 0. Right, this is, now you can figure out that what we can write this as. Look into this part only. Yeah, check for this part. What we can write this as? Can we write this as sine 2x over, this is actually 4x whole square. So that is 2x square. So instead of placing square in on numerator and denominator, I placed a whole square. Now what you have to see that 1x is left over here. Yeah, this is left. Now this is 8, and applying limit over here, using this, we are getting 1 over here. This is 8 into 1. But then placing x over here is 0. But anyway, it's not in the form of 0 by 0 form. So it's 8 into 1 is 8, multiplied by 0 is 0. So therefore, A is the correct answer in this case, option A. Now in the next question, we have to evaluate sin x over x into 1 plus cos x. Now, what should we do here is to apply trigonometric identity. What I can write sin x as, we can write this as 2 sine x over 2 cos x over 2, right? Because we know that sine 2x is 2 sine x dot cos x, that over x. And what is 1 plus cos 2x? And that is 2 sine square, that's cos square, 2 cos square x over 2. Now from here I can see 1 cos get cancelled. I forgot to place the limit, which I'll place in the next step. This is limit x tends to 0. Now check here. We have 2 over here. This is 2, and 2 get cancelled, right? These 2 get cancelled. So we are left with what? Sine x over 2, that divided by x. So in order to apply this, sorry, this sandwich formula. Okay, wait, we have 1 cos x as well. I can see that. So it's not going to be sine x, right? Now let me show you what I mean to say, that this is sine x by 2 and cos x by 2, right? So that should give you what? Tan x over 2. So I'll be writing tan x over 2, that divided by x. So you can see that in order to apply this identity, we need to multiply divided by 2 over here. So you can see that this half will come outside. So this is half will come outside, and then it is limit x tending to 0. That's going to be tan x over 2, that divided by x over 2. So that results to give you what? Half into this will give you 1, right? Applying this standard limit, I can replace this with 1. So therefore half is the answer. And the option here is, yeah, that's B is the correct option in this case. The question here is to evaluate this, right? Sine 2 plus x minus cos 2 minus x over x, which is given equals to p cos q. And what about p and q? These are the values which we have to determine in this case. Now, first, what we are going to do is to apply CND identity over here, right? Over here, we are going to apply this CND, trigonometric identity. So what we are going to get here, let's say we have limit as x tending to 0. This is sine c minus d is 2 cos c plus d over 2. This is 2 cos c plus d. What is c plus d? This is c plus d, that divided by 2. Make sure the here divided by 2 with the angle, and minus sine. Yeah, that's not minus sine. That is into sine c minus d over 2. So what is c over here? C is 2 plus x, and minus of this will give you minus 2x plus x, that divided by 2. And then we have a whole divided by x. Right. Now this is equal to P plus Q, right? The RHS is P plus Q, which we may write later on the next step. So limit x tending to 0. To simplify this, what I can see, this is here what getting cancelled. Here x get cancelled, and over here minus 2 get cancelled. So it results to give you 2 times cos 4. That's 2 plus 2 is 4, right? Cos 4 divided by 2 is what? Cos 2. That multiplied by sine. This is 2x, x plus x is 2x divided by x would give you sine x. And then I'll write this x over here only. So, and this is equal to what? This is given equals to P, as for the question, P cos Q. Right. So what we can see that this I can place outside the limit, and if I apply the sandwich formula over here on this part, applying this formula, it results to give you what? 1. So at the end, we are going to get, after placing the limit, it is 2 cos 2 into 1, and that results to give you 2 cos 2, which is equal to, if I see the RHS over here, that is equal to P cos Q. Now comparing these LHS, RHS, we get P as 2, and that's cos Q, and Q is what? Q is also 2 here. So we got this as, yeah, D is the correct option in this case. The next question is to evaluate this at limit x tends to 0. So what we will do first, we'll use trigonometric ratios here. We can write sine tan x as sine x over cos x. Let's see what we get if I convert this. So this is limit x tends to 0. I can write tan x as what? Sine x over cos x. So this is sine x over cos x, and then the minus sine x, that whole divided by sine cube x. This is sine cube times x. Now what I can see that I can take out sine x as common from here, right? So if I take sine x as common, that results to give you 1 over cos x minus 1, and then that whole divided by what? Sine cube x. So what you can see that here's one sine get cancelled, right? So we'll get sine square x over here. So this is now limit x tending to 0. If I take LCM in the numerator part, is going to give you 1 minus cos x, that divided by cos x, and we have sine square x in the denominator. So this is sine square x. I can write it over here. Now check, we can continue to apply trigonometric identity over 1 minus cos x is what? It should give you 1 minus cos x is 2 sine square x over 2, that divided by cos x. Check here, we can convert this also in terms of x over 2 by applying half angle property. Sine x is 2 sine x, this will give you, let me write down, 2 sine x over 2 into cos x over 2, right? This is applying sine 2x identity, that is cos x over 2. But then we have a whole square over here, right? This square is there. Now what next? I will be opening the bracket over here. Let's say if I write, this is limit x tends to 0. So this is in the numerator, this is 2 times sine square x over 2. And at the denominator, we have this cos x. Now if I apply the square over here, that results to give you what? The 2 will become 4, right? This is 4 times sine square x over 2 and cos square x over 2. I applied this square over here. And I can see that this get cancelled, right? This sine square x over 2 and cos sine square x over 2 get cancelled. This will get cancelled by 2 times. All right. So we can place the limit over here because cos 0 is what? Cos 0 is 1 and cos 0 over here will also give you 1, right? Placing x as 0 is going to be cos square 0 and cos square 0 is 1. So it's 1 in the denominator. So finally we'll get 1 over 2 because of this 2. So I can see we have an option that is A is the correct option in this case.